there and welcome to the Hashpower Academy. Fun fact, of the 100% of the world, barely 1% have probably got into Bitcoin. Now, if you zoom into that 1% and zoom it out, barely 1% of that 1% are into Bitcoin mining. And it is to say that if you look back in history, the pioneers, if you look today, the pioneers, and if you look into tomorrow, the pioneers of the future tend to be the rewarded the most, but they take the most upside risk. So the first thing to understand about the progressional steps into Bitcoin mining is that mining is the forefront of energy and technology innovation, and it takes no prisoners. But if you are here to learn, that is always going to be the first stage, because you can make these two progressional steps less painful in terms of finance, your time and energy, if you learn all of the absolute fundamentals and everything that can go wrong. That's the key thing. If you learn what can go wrong, you can understand and move through what's going right. So let's dive into this very interesting video. But first, let me introduce myself. Hello there and welcome to the Hashpower Academy. My name is Jake Scanlon. I'm the lead educator here, and this is a place for you to delve into anything and everything to do with Bitcoin and its underlying network of technologies and commodities. You can learn everything to do with how we produce energy, transfer it over time, how we produce compute power and transfer it over time, and how we produce Bitcoin blocks. And you can guess the last one, last but not least, how we produce Bitcoin and transfer it over time. All these different components are all interconnected through maths and physics to make the finance component last. Now, let's dive in. So, the three progressional steps into Bitcoin mining boil down to what I like to call learn, earn, and scale. Before you make the painful mistakes here and here, you better learn the basics. Now, the most key important thing is you need to start small. Start with something that allows you to understand how it all connects together. This little guy allows me to understand how much energy it consumes, how much hash rate it produces, and how much that earns in terms of a quantity of Bitcoin representative to the entire network. I'm going to put it over there. So the first thing to understand is you are not buying a mini miner to make a profit. This is an educational tool, and yes, they are one chip with a load of components, so they are more expensive, versus hundreds of chips with fewer components, shall we say. And so what you need to understand that you are buying something to learn. And what you'll understand is, okay, I plug it in, I consume electricity, it produces hash rate. I need to connect it to the Wi-Fi and connect that to either a pool or solo mining. So let's write pool, a mining pool, or you are taking the risk of going solo. Now, the problem with going solo is unless you find a block, you are not going to earn any Bitcoin. And the reason for this is, well, right now, if you spent $100 million at scale and divided that by $20 per terahash, you would have 5 million terahash. Now the network is 800 million. So divide 5 million divided by 800 million and then multiply it by your 144 opportunities per day to find a block. You will get an answer of 0.9. So to find barely one block per day, you need $100 million worth of mining hardware. So the chances of getting one in a day, very, very expensive, very slim to none. In a week, month, year, decade, thousands of years even, the chance to find a block with a BitAxe is very, very low. So the alternative to playing the game of lottery, because that's what it is, which is fine, you do that. The other chance is to use a layer 2 for payouts. Now the reason why you would want to use a layer 2 is because a mini miner is going to earn such a small quantity of Bitcoin relative to anything at scale that you would want to, well, still be paid out. But here's the thing, that a lot of the layer 1 payout, I'm going to just use orange. Layer 1 payouts, they require you to earn relatively $100, $200, $300 worth of Bitcoin at this moment in time. And with a mini miner, you are not going to earn that much. So the key takeaway here for this entire learn chain and everything on Hashpower Academy YouTube is delving into all these different pieces is you are interconnecting and learning about, okay, it consumes energy to produce compute, to produce Bitcoin, and I can be paid out, or I can play the lottery of trying to find a block of 3.2 Bitcoin. Or the optionality is run it into a pool and connect it to a pool that has lightning payouts, such as brains. It goes off to ant pool, but anyway, that's a topic for another day. And then when we're looking at the earn side of things, this is key and fundamental. You could have gone through stage 1 and bought a mini miner, but now you're looking at the economics. This is the important part. Everything to do with here is learning the technicals. With the stage 2, we're going into the financials, and then with this, you're going more into the electricals. So with this, you're understanding, okay, I want to economically mine, which is I want to understand a quantity of Bitcoin I could have purchased versus a terahash, for example. Okay, how much Bitcoin do I want it to earn? I want it to earn more Bitcoin than I could have just purchased in the first place. So economic mining is buying the power cheap and producing the amount of Bitcoin per kilowatt in greater quantity. So I can recommend, if your energy is less than 7 cents, you have the potential to self-mine, but you would want to get an efficient machine, a low joules per terahash. If you've got power at home greater than 7 cents, hosting is your opportunity there. But the key thing with hosting or self, let's just write these in, self, you might have a solar setup at home. Here's the thing, this is going to have different optionalities in all different places, but it's truly down to you, the individual. If you have your own solar setup already, you've got excess power. And I do invite you, if you have a battery, solar, or net metering setup with the grid, anywhere that you have excess electricity available to you, mining is an opportunity to visualize that kilowatt hour as a quantity of money, an ability to store the money in excess. So self or hosted. Right? Now, the next piece of this is the type of payouts. So this is going to be out of scope for this video, but mining pools have different payout types. So you're understanding the economics of, if you've got cheap power at home, yes, you could self-mine. But the sensible thing is most people don't have access to power, and that's why most people don't get into mining. And so if you have a hosted setup, well, you also have the option to probably decide which payout method you're going to use. The typical ones are FPP. Yeah, I always have to remember these. FPPS this is what the network is earning, and the mining pool is just paying you on those theoretical profits. So it's not what the actual pool finds itself in terms of blocks and then distributing it out to those miners connecting to their pool, but actually just what the network is earning. And there's some issues with, if fees spike and your pool captures those fees but pays you what the network earned, which wasn't that fee average, then you're missing out in certain places. But again, this is out of scope for this video. And the other one would be, say, P, L, and S. Again, out of scope. This is the pool finds a block, distributes that block in layman's terms. But the overall approach here is you're trying to understand the basics here of, I'm consuming energy, running it through my computer, I paid this amount, which is not great, but it's an educational tool. I could solo mine and lottery mine, or run it into a pool, connecting to the pool and getting payouts on layer 2, Lightning. And then with a machine, you're looking at the electrical decision, under 7 cents or 6 cents, 5 cents if you've got a less efficient machine available to buy. And if your energy at home is more than 7 cents, which the majority of people it will, yeah, it's hosting is your opportunity. And then with the price of the machine, this is the thing. Let's say you bought a 1 terahash machine for $200. But what if you bought a 200 terahash machine for $20? Combine that together, you spend a total amount of 200 times 20, that's $4,000, plus the $200 for this. So a total spend with one machine and one BitAxe Mini Miner, you've spent $4,200. And the total amount of hash rate you've got is 1 plus 200. So you do your 4,200 divided by 201, and your average your dollar per terahash average, when you've gone from this step to that step, which is one machine, you've lowered the cost of this machine by 90% almost by lowering it to $20.89 per terahash. So yeah, just by taking that step from buying a mini miner to buying a whole machine at $20 a terahash, you've lowered your average price in total per terahash to $20.89 per terahash. So that's just a way to move from the, oh, I overpaid per terahash to I've lowered it by going into the financial aspects. So just to recap, you're either mining at home because you've got cheap power, or you've got expensive power, so your only option is host. One machine is this example, but typical hosting setups, yes, there's platforms to buy one machine, but with these computers, the more you buy in bulk, you're going to get better prices. And so, yeah, there's typical sites that'll offer minimums of 10 machine purchase, or even 100 machine, or even a 1 megawatt minimum. But we'll go through that in a second. Your different payout options at the mining pool. So you're sending and exporting your energy onto the internet, and you can be paid out on the layer 1 side of things, a couple of transactions per month. There's different pools that define you want to be paid in a certain amount of time, let's say once a month or once a week. Or in certain quantity. A certain quantity is mined, and then they pay it out to which wallet of choosing. And typically, just about every pool doesn't charge you for fees. So you can be accumulating Bitcoin without fees through the electricity bill. That's another interesting angle. Now, this is where it all gets interesting. You've learnt the technicals of how it all connects together. You've learnt the financials of how the input cost and output Bitcoin and the machine in the middle that you're paying off over time. And you want to obviously get a cheap dollar per terahash rate. But the pricing of machines, the less efficient they are, the less Bitcoin per kilowatt they earn, they'll be cheaper. The more expensive machines, the more Bitcoin per kilowatt they produce. But you've still got to think of that input cost, output Bitcoin, your profit, and how many cycles of earning profit is it going to take to pay that machine off in time, your payback period, so to speak. And if you get that far, you've learnt lots. And most people will probably just make it to this stage of maybe one machine or a couple of machines, or running them at home, using it as an electric heater to heat your house or a pool or something like that. There's all different things that can take a lot of time and a lot of interesting directions that you can go with the earn side of this. But this is where it gets interesting, the scale. How big can this scale? Well, the basic parts, and I think they get more expensive as they go down, basically, is you could essentially get those payouts to your own hardware wallet. You're getting getting payouts to your own hardware wallet, so you're sovereign in your private key, so to speak, ish. Your own node. So that's the data side of things. If you are solo mining at this scale, which we'll discuss, you're going to be storing the data. Solo mining requires you essentially to store that entire transaction file. So this is where you're delving into nodes. So you could be having your own wallet to store the data money, storing the data, which verifies your data money, and adding those Bitcoin blocks, which is you're producing enough compute at enough scale to potentially add Bitcoin blocks to the chain in relative periods of time that align to your energy bill, because you've got to think of this as input energy bill, output Bitcoin. If you lottery mine one of these, you'll just about never mine a block. With this, it would take forever, but you'd essentially be just constantly paying an energy bill with no economic return. This is why we have mining pools, and there are different payout options and different payout levels in terms of the chain. And in terms of the Bitcoin side of things, yeah, this is, well, hang on, I'm going to write solo here and data here. I've written this the wrong way around. So, solo node. So everything to do with the data, that's the most important aspect here. If you're verifying your transactions, your trades, your issuance, all these sorts of things with your own node, your own information, and you could be solo mining, but this is where it gets interesting, because this is more focused on the compute side of things, that if you're scaling from hosted to I just want to continue to host, there is benefits to scaled hosting. And these sorts of benefits are demand response. When you have enough mining machines over, say, 1 megawatt of energy consumption, 1,000 kilowatts, that's when you can be exploring the option of doing demand response, which I've discussed on this channel as that opportunity that you have the Bitcoin price, your production cost, and the electrical grid rate sort of in the middle. And when the energy price goes above the rate of revenue, you switch off and sell power or underclock. And when the price of energy drops below your contractual rate of electricity, dollars per kilowatt or megawatt, when the energy price drops below or goes negative because there's a load of wind, a load of solar, but no one's using power, or the prices go negative, you will be paid to consume the power on top of that revenue rate of Bitcoin per kilowatt hour. And so demand response is the other side of the trade. You've got buying energy to produce Bitcoin, and then demand response is that the hurdle for this is to be producing about a megawatt. Demand response. So demand response is being able to energy trade. So with Bitcoin, you're sort of doing financial trade of consume energy in fiat and pay out in Bitcoin. And energy trading is you're selling energy to buy Bitcoin because you can sell the energy in a greater quantity. You can sell the energy to produce or earn or buy a greater quantity of Bitcoin. It's the other way around. And the other side of that is, well, yeah, this is the option of being on the grid power. The other option, and this is the fully stacked vertical option, is you're producing your own power. Could be as small as a single solar panel, battery if you want, producing that excess energy, running it into your own machine, producing your own Bitcoin, storing that information in your own node, and that money in your own wallet. That is you vertically integrated from watts to sats. So demand response is the grid side, but what would be the production side? I think it should be microgrids. The long-term path is if you producing your own power, why not have a community built around that where you're selling power at the rate in which you can turn that energy into Bitcoin? So that's electricity defined on a Bitcoin unit of account. And as we scale all different sorts of microgrids that consume Bitcoin, consume Bitcoin? Well, yes, that's correct. The microgrids that consume energy to produce Bitcoin, that defines a price for those kilowatt hours. Why would that miner want to switch the machine off to sell the power to his local microgrid? He would sell it at the rate in which he can earn the quantity of Bitcoin per kilowatt. And the more he sells the power, the more efficient the machine gets, so he can earn at that even higher rate. So the miner is incentivized to earn even more Bitcoin by providing energy abundance at that local level. That is so powerful to me. But the main thing here is produce your own energy, produce your own electricity, sell it locally at the rate of revenue of Bitcoin, and then that choice between using the grid, demand response, hosting the machines potentially, that's a minimum of about a megawatt, say 50 petahash, which is 50,000 terahash. Divide it all down, that's 20 joules per terahash efficiency roughly. And so the other option is you're producing your own power, maybe building out your own microgrid, Citadel, mini off-grid community. You're self-mining, you're running your own machines, and you're getting these machines at a cheaper price. This is the other thing. This would be spot buying your machine spot or a hardware reseller. This is you're buying at the scale of buying directly from manufacturer, which can be futures. And this is important if you're continually buying over time, because if you buy a machine and it's to be delivered in 5-6 months and you lock in a certain price per terahash, let's say 14. Let's say over the last 6 months that you're waiting to get your machines because you're still building out your energy production side and your land and your whatever else. Let's say the price of machines dropped to $10 a terahash. There are manufacturers such as Bitmain that will essentially let you hedge the downside price of machine devaluation, and they will give you credits essentially to buy more machines from them, of course. But it gives you a hedge. If you know you're going to continually buy more machines into the future, you have that opportunity to obviously lock in downside risk mitigation. Yeah, that's the overall gist. That might have been a little bit too much, but oh well. So it's, you produce your own energy, run it through your own machine, produce some compute, connect it to a mining pool or solo mine and pay out in the layer 2. Then you shift to the economics of buying a machine at a great enough volume of hash rate to get that price down, earn, say, a decent amount, decent payouts on the layer 1 blockchain without fees, typically. And that decision is typically decided by your electrical cost at home, or you don't want to run the machines at home. You want to obfuscate the electrical and technical aspects and just put the finance side up, which is hosting. And then if you want to scale that to producing your own power, running your own microgrid to source machines at volume or demand response trade on the grid, get hedging the downside risk of buying those machines and at a lower price with wholesale purchases, and that opportunity to either solo mine or run it into a pool. And the different options of running your own nodes, securing and verifying your transactions, and storing that Bitcoin in your own wallet. It can be as optional and simple as something at home that's small, or as big as a city and a multi-microgrids all around the world, but they're all priced at the same quantity of Bitcoin per kilowatt hour. I think that's going to be an amazing future, where inefficiencies of trade and logistics are reduced to the point where goods and services trade and money transfers through the internet in the opposite direction. Thank you for listening. I hope this was a very insightful video. If you have questions, drop them down below. If you want to get a mini miner, I think I have a link in the description, of course. And if you want to get into hosted mining, drop me a message or an email, and I will address the scale of investment that you're looking for at those sorts of quantities and give you some form of insight into what's available. But again, not financial advice. I'm not a financial advisor. And if you want to build a Bitcoin citadel, definitely drop me a message, because I'm finding people all around the world that seem to have this sort of dream in their minds of this energy abundant world. And I think that's what we should strive for, because the cheaper energy gets, everything just gets easier and more abundant. And that combination of energy and technology allows us to just operate in a world that is just so much more advanced and progressive towards the future, and all the parallels with AI and cloud computing as well. Thank you for listening. I hope you enjoy, and I'll see you in the next one. Goodbye.